Alright, so examples 3 and 6 you should have done on your own. And you can check those in the key, so we're going to jump to example 7. So to purchase a property worth $8,000, the buyer agrees to make 7 quarterly payments of $1,000 and then the final concluding payment at the end of 2 years. What is the size of the concluding payment if the interest rate is 6% compounded quarterly? Okay, so this is a little bit weird of a problem. So we have the $8,000 and then we make our $1,000 payments. Okay, and there's going to be 7 of those, so this would be the 7th quarter, so this would be 3 months later, 3 months after that, and then this is going to be at the 1 year, 9 month mark, because that would be the 7th payment. So we're making 7 payments, and then we're trying to find X, the last concluding payment, at the end of those 2 years. So again, we have the end of 2 years, and we're making 7 quarterly payments. Okay, so when you purchase something, you're not going to make a payment right away. Usually you make some kind of down payment and then you make your regular payments the next time. So that's why there's that gap. Okay, and again, we're trying to find the size of the concluding payment, so that's how we know that this is set up this way. And their interest rate is 6%, so that means our R is 0.06. So I compounded quarterly, and again we have compounded quarterly, so those are in agreement. We don't have to worry about any extra fuss here with an EIR or simple integers as part of a period, because that's taken care of, so we can just do straight up our leftover formula, jump straight to it. So again, with our leftover formula, we have to bring all these payments to the end, so that's going to be an SN due problem, and then this has to go all the way to the end, so that's going to go 1 extra payment, then the SN due, then the SN problem, so that is going to be that piece. Okay, so we're going to use the leftover formula after the 7th quarterly payment. Okay, that's what we're doing. So we're going to take 8,000 times 1 plus 0.06 over 4. Okay, and then we're going to do the 7 plus 1. So that means that term is really 8,000 times 1 plus 0.06 over 4 to the 8. And then we're going to subtract our 1,000. SMN 1 plus 0.06 over 4 to the 7 minus 1 over 0.06 over 4. And then we have our due, so we have 1 plus I again. I'm just going to rewrite that so we have the formula all in one spot. Okay, and then just entering that on the calculator, just because we didn't do that last time, so I want to make sure you guys have enough examples of it. We're going to do 8,000 times 1 plus 0.06 over 4 to the 8 minus 1,000 times, so this one is our numerator, this one's our 1 plus, and the numerator, divide by our denominator, then we're going to multiply by the 1 plus I again. So we get 1,579 and 10 cents, and again, rounding up to the nearest penny here with the leftover payments is going to depend on your bank, if they want to keep the fraction of a penny and just give the grace, or if they want to charge the borrower that penny. It's just going to depend on the lending party, so the bank or whatever you're dealing with. Okay, and this number makes sense because it should be bigger, because if we just divide 8,000 by 8, right, each payment would be 1,000, but that hasn't accounted for any of the interest. So we know that this should be over 1,000, right? That part makes sense.